Hello everyone. So today we are solving another question of JEE 2015. This is on the topic of atoms and nuclei. A nuclear power plant is supplying electrical power to a village, okay, which is using a radioactive material of a half-life T years as the fuel. The amount of the fuel at the beginning is such that the total power requirement of that village is 12.5% of the electrical power available from the plant. Okay, if the plant is able to meet the total power needs for a maximum period of n times the T years, then the value of n is. Okay, so basically, let's suppose, okay, first of all, let me clear this that the activity of the this reaction is quite proportional to the power here. Because how much is the activity, it is dependent on the power, directly proportional. Okay, so basically, we do not have to calculate power and all, we have to calculate in the uh, activity here. Okay, so it let's say initially we have activity as equal to A naught. Okay, which says if we use, I mean, let's write the requirement. What is the requirement of the village? It is given as 12.5% of this A naught. It means it is equal to 0.125 times of A naught. And when, still, like till when this company will be like sufficient to provide all the power here. I mean, this plant will be sufficient for that village. Only when the activity will be greater than this, when it will become less than this, so it will not be like self-sufficient for this company to provide the power. Okay, so what we have to do here, we know that the since all the decay are in the first order reaction, so they follow a equation like AT is equal to A naught e to the power minus lambda T, where lambda is the decay constant, which can be written as ln2 by T half, that is, okay, half life Ts is given also here. Now, this is the time here and this is the activity at that time. So when this will become less than this, then only we can say that it cannot, like, it can no longer be sufficient for that village. Okay, so what we have to do here, let me write the proper equation, that 0.125 times A naught should be like it should be greater than A naught e to the power minus, what is this, is equal to lambda actually. So lambda equal to ln 2 by T into the time here. This time we have to find. Okay, and we can write it as nt because we have to find anyways n here. So we will get n here. Okay, now on solving this equation, let's first take the log both sides, or the cancelling A naught and taking log both sides. So it will be ln 0.125 is should be greater than minus of ln 2 into n. Okay, so now if we do, yeah, let's like put this minus here and it will be in the minus 1. So we know that uh let me write the for the A times ln b is equal to ln b to the power a. Okay, so we can put this minus in here in the power, and what is 1 by 0.125? It is nothing but 8 here. So we can write ln 8 is greater than ln 2 into n. And if we divide ln 2 here, so ln 8 is nothing but 3 times the ln 2 divided by ln 2. This should be greater than n. So it means the at most year the power plant will be sufficient will be 3 years. So our 3 is the final answer here. And thank you everyone.